problem, although this is kind of perverse. We're going to ignore friction. We have normal, we have weight, we have the applied force F0, and we have this air resistance force kV, which seems a little weird. Now we want to derive the expression for the acceleration, so that means in the x direction, we know the car is accelerating. What we'll say is F0 minus kV equals ma. So if we solve for the acceleration, it's going to be F0 minus kV over m equals the acceleration. And that's pretty much the answer for B. For part C of the problem, let's just actually get a new page here. We're going to solve for velocity. And the way that's going to work is that we're going to actually say F0 minus kV equals m dv dt. And I'm going to do a little bit of calculus here. So I'm going to get dt over m equals dv over F0 minus kV. Now we're going to do this by u sub. So u equals F0 minus kV, and du is going to equal negative k dv. I also want to check the initial conditions. So they tell me that it is at rest at time equals 0. So notice that at t equals 0, u equals F0. So let's go ahead and actually do our substitution. So we have dt over m equals negative du, and I'll have a 1 over k out here, over u. So we're going to end up getting negative k dt over m equals du over u, and so we're going to end up getting negative k over m dt, negative k over mt equals the natural log of u plus c. So with that in mind, we can actually go ahead and do a little substitution here. So I know that at t equals 0, u is going to equal F0. So what that means is c is negative natural log of F0 if I'm actually going to solve this right. So now what I can do here is I can actually go on and write negative kt over m equals, and I'm going to use a logarithm rule here. That's going to be ln of u, which is F0 minus kv over F0. And I'll exponentiate both sides, so I'm going to end up getting F0 e to the negative kt over m equals F0 minus kV. I did a little bit of math there, which we'll actually have to follow. So when I actually end up solving, I'm going to get F0 over k times 1 minus e to the negative kt over m is my velocity as a function of time. That is part C of the problem. And by the way, if I asked you for the terminal velocity, that would end up being F0 over k, which you can check. All right.